Hello, welcome to lesson 10. In this lesson, we are going to look at examples on calculation of refractive index of liquids using a lens. Let's begin by looking at this first question. Two equiconvex lenses of focal length 20 centimeters and made of glass of refractive index 1.6 are placed in contact, and the space between them is filled with a liquid of refractive index 1.4. Find the focal length of the lens combination. So we have two convex lenses, equiconvex lenses. We are putting them together, and the space between them is having or is filled with a liquid of refractive index 1.4. So it means that we shall have the combination looking like this. Two convex lenses, this and that. In between you have a liquid. And that liquid is also now going to form a lens. So they want us to get the combination, the focal length of the lens combination. So we have the focal length of this, and then the focal length of that. So we also now need the focal length of this liquid lens, and then we shall get the combination focal length. So using, first of all, the convex lens, we shall get R. So using the formula, 1 over F1 is equal to N1 minus 1 into brackets 1 over R1 plus 1 over R2. So we need the R, that's the radius of curvature, or the radii of curvature for the two surfaces. So we shall have, but this R1 is equal to R2 because it is equiconvex. So R1 is equal to R2, which we shall call it as R. So we shall have our R, when we substitute, we shall get our R as 24 centimeters. Now remember that if this is 24, it implies that even for the concave is going to be 24, but it's going to be negative because it is concave. So for the radii of curvature, for the liquid lens is going to be negative 24 centimeters. And therefore we shall be in position to get F using the formula 1 over Fw is equal to Nw minus 1 into brackets R1, 1 over R1 plus 1 over R2. But remember, Nw is 1.4, and then R1, which is equal to R2, is equal to negative 24. Substituting that, we shall have Fw as negative 30 centimeters. So that's going to be the focal length of the biconcave lens or the liquid lens. And therefore we shall get the formula for the combination in order to get the F for the combination. So we shall have that formula, 1 over F is equal to 1 over F1 plus 1 over F2 plus 1 over Fw. And therefore 1 over F will give us this, and that means that F will be 15 centimeters. Let's continue. Number 2, a thin equiconvex lens of glass of refractive index 1.5 whose surface have radii of curvature 24 centimeters is placed on a horizontal plane mirror when the space, that's a full stop, when the space between the mirror and the lens is filled with a liquid, a pin placed 40 centimeters vertically above the lens coincides with its image, capture the refractive index of the liquid. So this is quite similar to the experiment. So if you remember so well the experiment for getting the refractive index of a liquid using a convex lens, this is the scenario. So it implies that we can first of all look at this question from, you can tackle this question by using the convex lens. They have given us information about the convex lens, that is the R, the refractive index, and then the radii of curvature. So using that we can get the focal length of that convex lens. So shall get using the formula, 1 over F1 is equal to N1 minus 1 into brackets 1 over R1 plus 1 over R2. Remember R1 and R2 are equal, so it is equal to 24. So we shall put 24 here, then this is 1.5, we shall get F1. So our F1 is going to be 24 centimeters. That is the focal length of the convex lens, the equiconvex lens. Now, and the focal length of the combination is actually the 40. If you remember so well the experiment, this 40, when you have placed the liquid, that's the focal length of the combination, the distance from the pin up to the lens. So that is the focal length of the combination. So we shall just get, if you know that, we shall get the focal length of the liquid lens. So now we are looking for the focal length of the liquid lens. I have the focal length of the convex lens, the focal length of the combination, so I can get the focal length of the liquid lens using the formula 1 over f is equal to 1 over f1 plus 1 over fl. And fl is going to become negative 60 centimeters. So that's going to be the focal length of the liquid lens. So after getting the focal length of the liquid lens, we can now get the refractive index of the liquid lens using the full lens formula, or the full thin lens formula. 1 over fl is equal to nl minus 1 into brackets 1 over r1 plus 1 over r2, where, remember, the upper part, r1, is going to have negative, it's going to be negative of 24, and then r2 is going to be infinite. So that is going to be this. Then we can get our NL as 1.4. 1.4. Let's look at number 3. The curved face of a plane convex lens of refractive index 1.5 is placed in contact with a plane mirror, full stop. A pin placed at a distance 20 centimeters coincides with its image. That means that when we place that, we show we are getting a convex lens, but it is a plano-convex. So the curved part, that part which is curved, the one which is going to be on the plane mirror. So when we put a pin up, remember the experiment, that will give us the focal length of that plano-convex lens. So we shall get the focal length of the plano-convex lens, and that focal length is actually the 20 centimeters. The distance from the pin up to the lens is 20. So F for the plano-convex is going to be 20 centimeters. Now they are saying a thin film of a liquid is now introduced between the lens and the plane mirror. Then the coincidence of the pin and its image is found to be at a distance of 100 centimeters. Calculate the refractive index of the liquid. So first of all, we need to know that we have information about the convex lens, the plano-convex lens. So we can get R of the plano-convex lens using the formula 1 over F is equal to N1. 1 over F1 is equal to N1 minus 1 into brackets 1 over R1 plus 1 over R2. When you substitute, we are looking for R. But remember, the upper part is going to be the flat or the plane, so that is infinite. So it's going to be 1 over infinity plus 1 over the lower part is going to be R2, which you don't know. So you're looking for R2. So R2 is going to be 10 centimeters. That is the refractive index. So that is the radius of curvature of the plano-concave, of the plano-convex lens. The radius of curvature of the plano-convex lens. Now, using this R2, I can now use this R2 to get the refractive index of the liquid, because it means that for the R for the plano-convex, because now the R for the plano-convex is going to be similar to the R for the plano-concave, which is actually the liquid lens, because when we put a liquid, then we are going to have a plano-concave for the liquid. But now we need to first get the F for the plano-concave. That is the focal length of the plano-concave. I have the focal length of the combination, and I have the focal length of the lens, the plano-convex lens. I have the focal length of the plano-convex lens and focal length of the combination. So I can get the focal length of the liquid lens using the formula 1 over f is equal to 1 over f1 plus 1 over fl. So fl will be negative 25 centimeters. So that's the focal length of the liquid lens. After getting the focal length of the liquid lens, I can get the refractive index of the liquid using the formula. That is the thin lens formula, the full thin lens formula. 1 over f L is equal to NL minus 1 into brackets 1 over R1 plus 1 over R2. Now let us see how we are going to substitute. This one is negative 24. This one is NL we are looking for. 1 over R1. Remember, when we consider we are going to have curved and then plane down. So that's going to be negative 10 centimeters. So R1 is negative 10 centimeters. And then the lower part is infinite, plane. So it means that R2 is going to be it's going to be infinity. R2 is going to be infinity. So when we substitute, we shall have this. So we shall have 1 over infinity plus 1 over negative 10. So we shall have our NL as 1.4. Let's look at number 4. A small quantity of a liquid of refractive index 1.4 is poured on a horizontal plane mirror, and a biconvex lens of focal length 30 centimeters and refractive index 1.5 is then placed on top of the liquid. The pin is moved along the axis of the lens until no parallax between it and its image. Find the distance between the pin and the lens. Remember, the distance between the pin and the lens in that case will become the focal length of the combination when you have placed in that little quantity of liquid. So what you are going to do is get the combination, the focal length of the combination. That's what we want. Now let us first see the information given. They've given us information about the liquid, the refractive index of the liquid, and they've also given us the refractive index of the biconvex lens, and they've given us the focal length of the biconvex lens. So I have the focal length of the biconvex lens. I need the focal length of the liquid lens in order to get the focal length of the combination. So using the information about the biconvex lens, the 30 and the 15, I can get the R for the convex lens. That is the radii of curvature. So using the formula, 1 over F1 into brackets 1 over into brackets N1 minus 1 into brackets, using the formula 1 over F1 is equal to NL minus 1 into brackets 1 over R1 plus 1 over R2. This is R1 and it's equal to R2 because it is biconvex, and is equal to R, which is actually going to help us to get that R. So we shall get our R as when we substitute 1.5, 30 here, we shall get our R as 30 centimeters. So that means that the radii of curvature is 30 centimeters for the biconvex lens. Then after that, we shall use this to get the focal length of the liquid lens. Remember, I have its N is 1.4. So using that formula still, where NL is 1.4, we shall substitute 1.4 here, then look for this. Remember, this is the lower part is going to be flat, the upper part is going to be concave. So this is going to be 1 over negative of 30. R1 here is going to be actually negative 30, and R2 is going to be infinite. So we shall have this, and then we shall get our FL as negative 75 centimeters. Then we shall get the combination formula. Using the combination formula, 1 over F is equal to 1 over F1 plus 1 over FL. We shall have our F as 50 centimeters. So the focal length of the combination is 50 centimeters, which implies that the distance between the pin and the lens is 50 centimeters. Lastly, let us look at this question 5. In an experiment to determine the refractive index of of paraffin, the apparatus was first set up using a convex lens of focal length f. Convex lens of focal length f. Some water of refractive index 4/3 was placed on the mirror and the lens on top. Good. A pin placed at a height h1 vertical above the lens coincides with its image. So that means that is the focal length of the combination of the lens, the glass lens, and then the convex lens, and then the liquid lens. So that is h1. The experiment was repeated using paraffin instead of water. So we repeat the same thing using paraffin instead of water, and the new position of coincidence was found to be h2. So that means that the new focal length of the combination of the lens and then the convex lens and then the paraffin lens is h2. The combined focal length is h2. Show that the refractive index NP of the paraffin is given by NP is equal to 1 plus h1 into brackets h2 minus f divided by 3h2 into brackets h1 minus f. So when we look at this, we are going to start by looking at the combination of the lens-water combination, that form the lens-water combination. The lens-water combination. So that is going to be 1 over f is equal to 1 over fw plus 1 over f. Actually, 1 over, because the other now is going to be h1. So it's going to be 1 over h1 is going to be 1 over fw plus 1 over f. So that is going to be equation 1. But also we know that we can get 1 over f using the full thin lens formula. 1 over f is given by 1 over fw is equal to nw minus 1 into brackets 1 over negative. Remember, it is going to be plano concave for that water lens. It's going to be plano concave. So it's going to be 1 over negative R1 plus 1 over infinity, because the lower part is flat, where n is 4 over 3. So when you substitute 4 over 3 here, this is 1 over infinity is 0. So we shall just have our 1 over w. 1 over fw is as this. So we make 1 over fw the subject. We shall get our 1 over fw as negative 1 over 3 r1. Then we shall substitute this in equation 1. Where there is 1 over fw, we shall put in this. Then we shall get 1 over h1 is equal to negative 1 over 3 r1 plus 1 over f. From this, I can make R1 the subject, and R1 is going to be H1F into brackets, H1F divided by 3 into brackets H1 minus F, and we shall call that equation 2. Then after that, we shall also consider now the water, and now we started by considering the water-liquid combination. We shall now consider the second case when you have placed in the paraffin, and shall consider the paraffin lens combination. Paraffin lens combination shall have the paraffin and then the convex lens combination. That is H2 is equal to 1 over H2 is equal to 1 over Fp plus 1 over F, where H2 is the focal length of the combination. That H2 is the focal length of the combination. That is the paraffin lens combination. And then still, we also know that 1 over Fp can also be got using this equation, similar to this, because it's still also going to be a plano concave. It's going to be a plano concave. So we shall make our NP the subject, 1 over Fp the subject. We shall make our 1 over Fp the subject from here. Then after we shall put this in equation 3. When you place that in equation 3, we shall have this, and then from this we shall make NP the subject. So you do your simple mathematics here and make NP the subject. And when we make NP the subject, we shall call that equation 4. Then we shall put equation 2 into equation 4. So where there is R1, we shall substitute it with this. And when we substitute, we shall have this. And when we multiply the brackets, that will give us NP as 1 plus h1 into brackets h2 minus f divided by 3h2 into brackets h1 minus f. And that is going to be as they wanted us to prove. Yeah, thank you for your attention. We meet in the next lesson.